Okay, YouTube, in this video we're going to be solving exponential equations. So just a few quick examples of how to do so. We're going to take advantage of two properties that are often used, but those are our one-to-one as well as inverse properties. So I'm going to list those up here on the left before we go ahead and start. Our one-to-one property essentially says this: two things with the same bases, if they are equal on either side of an equation, well then it must imply that x equals y. Their exponents must be equivalent. And the other property simply says this: if you were to take the log with the same base as the base of an exponential expression, so like log base a of this exponential thing a to the x, you notice they have the same bases, then necessarily that's going to equal x. So in other words, a log would kill off an exponential thing and leave you behind with just the exponent. So that being said, let's go ahead and take a look at letter A here. It says e to the negative x squared is equal to e to the 5x plus 6. If you haven't already guessed this, this is our one-to-one property. We're basically saying two things with the same basis here. They both have base e. If they are equal, then it must be the case that their exponents are also equal. So we can now determine that negative x squared must be the same thing as 5x plus 6. This is very much quadratic, this situation, so what we can do now is just this. Let's set it equal to 0, and it is most convenient to take this negative x squared and kick it to the other side so that our leading coefficient will be positive when we solve something quadratic. So we have x squared plus 5x plus 6, and this is going to be equal to 0. I kind of swap sides, but at this point it's just convenient to go ahead and factor. I mean, we don't have to use quadratic formula here. We could if we needed to in a weird situation, but we say plus 2 plus 3. And so it is the case that we end up with x equal to negative 2 and x equal to negative 3. And it is very, very appropriate to actually plug this back into the equation and check them both. Okay, so we want to check both of these answers just to make sure that neither of them actually doesn't satisfy the original equation. So just as a real quick check here, what if we plugged in negative 2? So we'd have this. We'd say e to the negative 2 squared is equal to e to the power of 5 times negative 2 plus 6. So we get on the left here, we get negative 2 squared is 4, but this becomes e to the negative 4. And on the right here, we get negative 10 plus 6 up here, upstairs, and so this actually becomes e to the negative 4. So this one checks out. Just going ahead real quick and checking the other one, we say if we plug in negative 3, we get e to the negative 3 squared is equal to e to the power of 5 times negative 3 plus 6. Check our exponents again. We get negative 3 squared is 9, but that's got a negative in front of it, so this becomes e to the negative 9. And on the right here, it looks like we get negative 15 plus a positive 6, which is also e to the negative 9. So both of these solutions work. We don't have any what we call extraneous solutions. Okay, extraneous is that key word there. Letter B up here on the top right. Okay, so the important thing is this: when you solve, say, an exponential equation, the first thing we want to do is we want to find the exponential phrase. Okay, so that'd be the 3 to the x here. We need to isolate our 3 to the x, which means this 4 out front has got to go, and we're taking the 4 currently times this 3. So what we'll do is we'll divide both sides by 4. Okay, so we get 3 to the power of x is equal to 16. So now to undo this exponential thing, what we'll do is we'll take the log of both sides. It's just that when we take the log of both sides, we want to take the log that's going to cancel out with this exponential base of 3. So we'll take the log base 3 of everything on the left, and so this log base 3 and the 3 cancel, and I'm left with x. And on the right, I basically just have log base 3 of 16. So x is equal to log base 3 of 16. So this is where our change of base formula is going to come in play. Recall that change of base says this: if you have log, say, base a of x, then that would be the same thing as like ln of x, or the big item over here, over the ln of the base, or the smaller of the two items over here. And so this would actually be the same thing as the expression we started with. So over here, using change of base, we could say, well, this is the same thing as ln of 16, which is our larger of the two numbers, is how I think of it. And then we say ln of 3. And so ln is nice because our calculator actually has an ln button on it. If we go over to our calculator now, ln of 16, so we can do this. We say ln 16 equals, I need an end parenthesis, it seems, equals, okay, and we'll take this and we'll divide it by ln of 3, and we get 2.523, or 2.523, 2.523. And again, we could check this. We could say, well, 4 times 3 to the power of approximately 2.523 should come out to be 64. And just to check this, we say 3 to the power of 2.523, 3 to the power of 2.523. Oh, wrong button. So we have clear. You can kind of see this up here. 3 to the power of 2.523, enter, times our 4 that was out front, times 4. And you can see that it's not perfect, but we get approximately 64 because we were using a rounded decimal. Now this last equation down here, it's also exponential. It's got this e to the x hanging out. The thing is, we have to isolate the exponential thing on the left side of this equation, or one side or the other, but that means that our 5 here has to go and our 3 has to go. So let's go ahead, we subtract 5 from both sides, and so you end up with negative 3e to the x is equal to negative 3. Now we can divide both sides by negative 3. So we get e to the x equals 1. So now in order to undo this logarithmic expression here, we'll just use to undo the exponential expression, we'll use a log with the same base. So we end up with ln of everything on the left and ln of everything on the right, and so this would yield x equals ln of 1. And so if you know your stuff here, ln of 1 is a special property. We say this just comes out to be 0. But if you needed to check this on a calculator, we could verify this. Ln of 1, guaranteed money. You get 0. And so we could plug this back in and check it again. And essentially what this would say is 5 minus 3e to the 0 equals 2. In other words, e to the 0 is 1. So we get 5 minus 3 is 2, and 2 equals 2. Gravy. So there's a few examples.